This is Dr. Manjunath Chennapur from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is Otto Cycle and what are the important processes are there in Otto Cycle. Okay, how it works, what is the working principle of Otto Cycle, that we have studied in detail. And also we done an derivation for efficiency of an Otto cycle. Today I am going to do some numericals on that Otto cycle. Okay, so today I am going to do some numericals on Otto cycle. Okay, so numericals are problems on Otto cycle. So first problem, I will read the problem first. An engine of 250 mm bore and 375 mm stroke works on a constant volume cycle. Constant volume cycle means what? V equal to constant. That means what? Heat addition and heat rejection at a constant volume. That we can call it as a constant volume cycle or Otto cycle. Okay, fine. Full stop. The clearance volume is 0.00263 meter cube. Full stop. The initial pressure and temperature are 1 bar and 50 degrees Celsius. If the maximum pressure is 25 bar, find first one, air standard efficiency of a cycle, air standard efficiency of a cycle, then mean effective pressure. These are the two findings we need to calculate. For that, what we have to do? We have to draw the PV diagram and TS diagram for a constant volume cycle or Otto cycle. What is the PV diagram? That we already know. This is what PV diagram, this is PV diagram, and this is what TS diagram. What is the important four processes of Otto cycle? Point 1 to 2 adiabatic compression, point 2 to 3 heat addition at constant volume, 3 to 4 adiabatic expansion, 3 to 4 adiabatic expansion. So the next 4 to 1 heat rejection at constant volume. Okay, so then 1 to 2, whatever the volume we are having, right, that we can call it as swept volume. 2 to, then from here to here, this is cylinder head actually here, that distance between cylinder head to the here we are going to get the TDC, that we can call it as a clearance volume. What is this clearance volume and swept volume? I will tell you. Okay, so now this is what the PV diagram. Then TS diagram, to know the variation of temperature versus entropy, we are having TS diagram here now. 1 to 2 is what? Compression. 1 to 2 is a compression process. The next 2 to 3 is what? Heat addition. 2 to 3 is heat addition, that is QS. Again what? At constant volume, so volume remains constant, heat addition. Next 3 to 4. 3 to 4 is heat rejection. Again volume remains constant. Sorry, 3 to 4 is a adiabatic expansion. Adiabatic expansion. So 3 to 4. Next 4 to 1. 4 to 1 is what? Heat rejection. That heat rejection is represented as QR. Again that heat rejection takes place at a constant volume. If it is a heat addition, heat rejection takes place at constant volume, that we can call it as a constant volume cycle or Otto cycle. Dear students, he has given an Otto cycle. Then he has given some data here now. What are the data? 250 mm bore. That is 250 mm bore means what here now? Bore is represented as capital D, or some authors they will take small d. It's up to you. That is bore. Bore is nothing but what? The inside diameter of the cylinder. That we can call it as a bore. That is represented as a D. Then stroke length he has given. The bore diameter, how much he has given? D is equal to, he has given 250 mm. So 250 mm he has given. Convert it into meter. That becomes what? 0.25 meter. Then he has given next 375 mm stroke. The stroke is nothing but what? The stroke or stroke length we can call, that is represented by what? L actually. The piston moved from BDC to TDC. That distance we can call it as a stroke or stroke length, that he has given. L equal to 375 mm he has given, converted into meter, so therefore L equal to 0.375 meter. Fine. Next the clearance volume. Dear students, you can see here now, when it is a TDC, right, I will mark here, just you can just observe. Okay, at point 1 you can call this, we can call it a BDC, right? BDC. So BDC, then we are going to call it as a TDC here now, right? TDC. The distance, the volume between BDC to TDC, we can call it as a swept volume, or we can call it stroke volume. Okay, when the piston have some volume right here now, sorry, when the cylinder going to have volume between BDC to TDC, we can call it as swept volume. The volume between cylinder head, here we can call it as a cylinder head. The volume between cylinder head to TDC, we can call it as a VC. That is nothing but what? Clearance volume. When you are going to add this VC and VS, we are going to get one more volume. That volume we can call as a total volume. The total volume is nothing but what? It's a summation of swept volume and clearance volume. Okay, that data he has already given. Okay, and one more thing, dear students, in the problem itself he is telling that when his piston is at point 1, you can mark it as, for our understanding, point 1, and we can mark it as a point 2. For our understanding, when it is a piston as point 1, initial condition before compression, when it is going to start the compression, right, that starting point we can call it as a point 1. Okay, at point 1, what is the pressure? He is telling P1 is equal to the pressure of the air fuel mixture at point 1 is 1 bar. Okay, 1 bar, and temperature T1 is equal to 50 degrees Celsius. Yes, he has given. That is fine. Then when it reaches, now when it is going to compress, and when it is compresses point 2, at that, when it reaches point 1 to point 2, when it reaches TDC, right, at that moment what we are doing, at constant volume we are going to supply heat. When we are going to supply heat, then what will happen? The heat addition will take place, right? Then what will happen? The explosion will happen in the gas. Hence what will happen? Pressure is going to increase from P2 to P3. So maximum P3 is equal to how much? That he is telling now. Initially it was 1 bar and 50 degrees Celsius. Then when we are going to supply heat, right, it is going to attain the maximum pressure in the cycle is 25 bar. Maximum pressure in the Otto cycle is 25 bar only. This is the maximum pressure point you can see in the PV diagram. Fine. If it is the case, then how much efficiency we can get? If it is operating at 1 bar and 50 degrees Celsius and 25 bar, what efficiency I can get here now? That we need to calculate. First parameter. Second parameter, if it's so, what is the mean effective pressure now? When we are going to supply heat, right, that explosive force is going to create over the surface of the piston. That explosive force or pressure is called as a mean effective pressure. That mean effective pressure is written as a, P mean effective pressure, PE, M is equal to how much we need to calculate. To understand this concept, to understand this problem better, I will show some more in detail terms which are used in this particular solution of problem. Okay, what are those? You can see, students, if you want to solve this problem, so we need to know these all parameters here now. What are the all parameters? So now, to calculate mean effective pressure and air standard efficiency, we require some supporting informations or data. What are those? You can see here now. Network. To calculate the mean effective pressure, we required network and swept value. How to calculate the swept volume? Swept volume is the volume between what? The volume between BDC to TDC. That volume we can call this a swept volume. So piston displacement volume also we can call. Fine. Next, to calculate the swept volume and mean effective pressure, he has given some basic data in the problem itself. What is that? Bore. Bore is nothing but what? As I told, small d. He has given. How much he has given? 0.25 meter he has given. Fine. Next, stroke length is represented as a L. How much he has given? 0.375 meter he has given. Then, as I told, clearance volume also he has given. As I told, dear students, here to here it is what? BDC. Okay. TDC, it is what? Swept volume VS. It is nothing but what? Clearance volume VC. So now clearance volume also he has given, that is 0.00263 meter cube also he has given. When piston is at point BDC or point 1, he has given some pressure. That pressure is represented as a P1. Then when it is at point 1, it is going to have a temperature. The temperature is T1. When it reaches the maximum pressure, that maximum pressure is represented as a P3. P3 is equal to 25 bar he has given. P1 is equal to how much he has given? 1 bar. T1 initial temperature he has given 50 degrees Celsius. These are all data he has given now. Fine, dear students. Now, to calculate mean effective pressure and air standard efficiency, we required compression ratio, because we know we already done the derivations. Efficiency, to calculate efficiency, RC is the important parameter. Now RC is the important compression ratio. What is compression ratio? Compression ratio is the ratio of total volume to the clearance volume. Some authors, dear students, keep it in mind, some authors they will take small r, some authors they will take capital R, some authors they will take RC also. Some authors they will take small r, small rc. RC. Okay, so now I will take capital RC here now. Compression ratio is nothing but what? It is the ratio of total volume to the clearance volume. Total volume is nothing but what? So total volume, as I told, total volume, how we can calculate now? Total volume is nothing but what? Summation of swept volume plus clearance volume, that is nothing but Vt is equal to Vs plus Vc. So therefore compression ratio is equal to total volume, that is Vs plus Vc divided by Vc. This is nothing but what? Compression ratio. Once you to calculate this compression ratio, what are the important two things you have to remember here now? Total volume and clearance volume. Total volume is nothing but, total volume is nothing but, it's a combination of clearance volume plus swept volume. This clearance volume is Vc, swept volume is Vs. So therefore Vt is equal to Vs plus Vc. Once you know the total volume, we can calculate the you can calculate the compression ratio. So once you know the compression ratio, easily I can calculate the air standard efficiency. So to calculate air standard efficiency, compression ratio is also required, specific heat ratio is also required. This is about the basic understanding of the problem. So now I will try to list out the given data, dear students. Now what are the given data? You can see here now. Maximum pressure, that is 25 bar he has given, that you can put it in terms of kilopascal, that is 2500. Okay, clearance volume that he has given, that is 0.00263 meter cube he has given. Then bore he has given 250 mm, converted to meter is 0.25. The next stroke length he has given 375 mm, then converted into 0.375 meter. Then initial pressure is 1 bar, then initial temperature is 50 degree Celsius. These all some engine parameters are he has given in the initial itself. Now this is about what? How to understand the problem. We understood the problem with all the required informations. Now I will move towards next. Now how to solve this problem? There are some important steps now. First, what you have to do? You have to identify the given data. Next, you need to calculate the T2, because he has given T1, but he has not really given T2 and T3, that we need to calculate. Not only T2, P2 also not given, that we need to calculate with the help of what? Pressure ratio. Okay. Third step, calculate the air standard efficiency. Once you know the value of P2, T2, compression ratio, you can calculate the air standard efficiency. Then calculate the displacement volume. Displacement volume is nothing but what? Swept volume. With the help of piston, TDC and BDC, with the help of bore and stroke, we can calculate the swept volume. Once you know all these things, we can easily calculate the work done per cycle. Once you know all these parameters, once you've done calculations for all the above the parameters, then what I can do? I can calculate the mean effective pressure. So, dear students, this is our second parameter, right? So second finding, to calculate this mean effective pressure, it requires some data here now. Temperature at end of the compression, that is nothing but what? T2 we need to calculate. Temperature at end of the heat addition, that is what? T3. But T2 and T3 is not at all given. But in the problem he has given only T1, that to 50 degree Celsius he has given. But T2 and T3 we need to calculate. If we really want to calculate the mean effective pressure. So then what we have to calculate? We have to calculate QS, we have to calculate the work done. Once you know all this data, we can easily calculate the mean effective pressure. Once we've done all the things, with the help of air standard efficiency formula, we can do the calculations. So to do this, to calculate the mean effective pressure and air standard efficiency, we require some another basic datas. Those are swept volume and compression ratio. With the help of formula, we can calculate the compression ratio and swept volume. How to do that? I will teach you step by step here now. So what is first step now? What is first step? You have to mark the given data. So dear students, as I told, some authors they will use notations differently. They have taken small d here, nothing but what? Bore diameter. Some authors they will take capital D. So better to take capital D. But here they have taken D, small d, it's okay. D 250 mm, stroke is 375 mm, clearance volume is 0.00263 meter cube they have given. Initial pressure 1 bar they have given. Temperature 50 degrees Celsius they have given. Converted into Kelvin by adding 273, it becomes what? 323 Kelvin. Then maximum pressure they have given, that is 25 bar. These are the given data I have listed in the first step. That's fine. Now to find the air standard efficiency, we done the derivations in the previous class, right? What is the equation now? So to calculate the efficiency of the Otto cycle, we are having an equation. What is that equation? Efficiency of Otto cycle or air standard cycle, that is theta air is equal to 1 minus 1 divided by RC to the power of what? Gamma minus 1. This is the equation. Okay, so now to calculate this, what are the unknowns are there? Just two you need to list out now. First one is RC, another one is gamma. Gamma is nothing but what? Specific heat ratio, that is constant per air, that is 1.4. But only one unknown is here, RC. That is nothing but what? Compression ratio. Compression ratio can be calculated with help of an equation. RC equal to what? V1 by V2. Dear students, as I told, when piston is at 0.1, right? So we can call it as a V1. The whatever the volume which is accumulated at the top, that is total volume, we can say. When it reaches 0.2, right, that I can call it as a V2. When the whatever the volume is going to left out, right, that is nothing but a clearance volume. That's the, so therefore V2 is equal to clearance volume, V1 is equal to total volume here now. So therefore, what is now? RC is equal to what? Is the ratio of total volume to the clearance volume, that is what? V1 by V2. Or what is V1 now? V1 is the total volume. How to calculate the total volume? We already know total volume is nothing but what? It's a summation of swept volume plus swept volume and clearance volume. That is the same thing I have written it here now, Vs plus Vc. So Vs plus Vc, but Vc already we know, dear students, but we don't know the Vs. We can calculate Vs with the help of a formula. What is that? Stroke volume or a swept volume. We are having an equation. What is that? Vs is equal to 5 by 4 into d square into L. So that is equal to 5 by 4 is the constant, d is the bore diameter he has already given in terms of meter, that is 0.25 square, into what is stroke length, that is 0.375, is equal to what will happen now? Do simplification, you are going to get 0.0184 meter cube. That is what? Swept volume or stroke volume. Once we know the stroke volume, already Vc is already given in the problem, that is 0.00263 meter cube he has already given. Once we know the value of Vc and Vs and Vc, we can easily calculate the air standard efficiency. So therefore RC, now calculate RC value here now. So RC you want, right? RC you can calculate. RC is nothing but what? RC is equal to Vs plus Vc divided by Vc. So Vs is 0.0184 plus 0.00263 divided by 0.00263. Then what we will get? RC is equal to 8 actually. So compression ratio for an Otto cycle per given data is 8 actually. Once you know the value of RC, substitute all the values in the air standard efficiency formula. So therefore efficiency of air is equal to 1 minus 8 you have substituted, divided into 1.4 is the specific heat ratio for air is constant, that is 1.4 minus 1. To simplification, you are going to get 0.564. Then multiply with what? 100. Then what will get? You will get air standard efficiency. So air standard efficiency as a 56%. This is the first parameter, dear students. Now second, what to do now? Second step, you need to calculate the mean effective pressure. To calculate that mean effective pressure, we are having an equation. What is that equation? Mean effective pressure, MEP. Some authors they will take MEP, mean effective pressure. Some authors they will take P suffix M, mean effective pressure. That is equal to P1 into RC to the power of gamma into alpha minus 1 whole bracket whole divided by into bracket gamma minus 1 into RC to the power of gamma minus 1 into double bracket. This is the equation what we are having. So dear students, you can see here now, if you want to calculate, if you really want to calculate the mean effective pressure, what are the unknowns here now? P1 he has already given in the problem, that's okay. To calculate mean effective pressure, what are the unknowns here now? That I will try to list out here now. P1 is given in the problem, RC you already calculated, gamma is the constant, that you know already. Then only one is what? Alpha. Okay, that you need to calculate. Again, gamma is there, RC is there, gamma is there. Only one is alpha. Alpha is nothing but what? It's the explosion ratio. So from the diagram, you can see that alpha is nothing but what? Explosion ratio, that you can see here, dear students. Okay, so that is nothing but what? Here. So P3 by P3 by explosion ratio, because as I told, explosion is going to take place here, right? That explosion ratio we need to consider here now. So therefore, what is that equation? So alpha is equal to P3 by P2. But what is P2? P2 is given or not? No. But maximum pressure P3 has given, but P2 is not at all given. But that P2 we can calculate. How to calculate with help of an adiabatic equation? What is that adiabatic equation? We can say an adiabatic process. Adiabatic process. Adiabatic, which process I need to take here now? Adiabatic compression. Dear students, 1 to 2. Adiabatic compression process I will take. With help of that, what I will do? I will try to take the value of what? P1, P2. So P1 by P2, we are having an equation. P1 by P2 is equal to V2 by V1 to the power of what? Gamma. So what is P1? That he has already given, but P2 is unknown. I will try to calculate P2 by using this equation. What is V2? Yes, V2 is already given. That is clearance volume. What is V1? Total volume. That also already he has given. With help of that data, I will try to calculate the V2. So before going to that, we should know what is P1. He has given. V2 is nothing but what? Our VC. That is clearance volume. Then V1 is nothing but what? Our total volume. So therefore, total volume is equal to Vt, or V1 is equal to Vc plus Vs. So therefore 1 divided by I will put all the values in the above equation, this equation. So 1 divided by P1 is 1 divided by P2, I don't know, I will keep it as it is. P2 is equal to V2 0.0263 into V2, then divided by what? V1 divided by V1 is total volume. The total volume is nothing but Vs plus Vc. 0.026 plus 0.0184 to the power of what? 1.4. Do some simplification. You are going to get the value of P2 as 18.36 bar. Once you know the value of P2, now what we can do here now? We can calculate the alpha. Once you know the value of alpha, you can substitute that alpha into this equation. You can easily calculate the mean effective pressure. So dear students, you can see it in the bracket. To calculate the mean effective pressure, we are having this equation where P1 represents initial pressure, then RC represents compression ratio, gamma represents specific heat ratio, and alpha represents explosion ratio. That whereas alpha value is P3 by P2. So therefore alpha is equal to P3 by P2. Now what we done? We calculated the P2 now. Now we will try to calculate the mean effective pressure. How to calculate the mean effective pressure? We using that equation. So dear students, now I know, as I told, alpha is equal to P3 by P2. What is that equation? You can see here now. P3 by P2. What is P3? Dear students, small corrections here. It is not 2.5, it is 25. 25 bar 18.36. What you will get? You will get alpha value. Once you know the value of alpha, you can easily calculate the mean effective pressure. This is the equation for mean effective pressure. Substitute all the values now. P1 1 bar, RC 8 you already calculated, gamma 1.4. Then explosion ratio 1.36 that you already calculated, minus 1. Again gamma 1.4 minus 1, then RC is 8, then gamma 1.4 minus 1. You substitute all the values and do simplification. You are going to get mean effective pressure as PM is equal to 1.33 bar. So dear students, this is how to calculate the mean effective pressure. Dear students, mean effective pressure can also be calculated in another way also. What is that? So mean effective pressure, that is MEP, can also be calculated with help of another method or another formula. What is that? So MEP is equal to work done divided by stroke volume. What is work done? That is nothing but what? QS minus QR. We already know in the Carnot engine, we know already QS minus QR. Heat supplied minus heat rejection is the total work done to stroke volume. Stroke volume is nothing but what? V1 minus V2, or else V2 minus clearance volume. Clearance volume we can take. With the help of this equation, I can calculate the mean effective pressure. So how to calculate the mean effective pressure? With the help of this equation, that is mean effective pressure, that is work done by stroke volume, that is QS minus QR by V1 minus V2. That I will do it in the next video. Dear students, here with I request to please do subscribe my channel, like and comment and share. Please support my channel. Thank you.